screen share to you.
Perfect. Confirm that you can see my screen and that you can hear me well.
We can hear you well, and we can see your screen.
All right, perfect. Thank you very much for the introduction, Angel. Hi, everyone. Good evening, good afternoon, or good morning, depending on where you are. My name is Gonzalo Marcos. I'm an architect of MuleSoft. I'm based in the London office of the customer success team. The topic for today is networking, in particular the VPCs. This is a very recurring topic. Almost customers in EMEA have doubts at the beginning on how to go about creating their first VPC. So for that reason, what we are going to do in the next 40-45 minutes is to explore, if not everything, almost everything before creating our first VPC. And for that, the agenda that we have for the next 40 minutes is this. First, we will start from the basics. We will take a couple of minutes to understand what exactly is a Mule VPC. And also, I would like to think with me. I would like you to think with me, why do we need a VPC? Okay, first, we need to understand the concept, and then we need a VPC. And if so, I would like you also to think with me, how many VPCs do we need for our deployment? Many customers understand the concept of a VPC, but sometimes they struggle to identify the number of VPCs that they should be creating for their requirements. And finally, we will dedicate a few minutes to understand the concept of the CIDR block and how to choose the right size of your CIDR block in your VPC. All right, so let's get started. So one of the first tasks you do in the initial setup of your endpoint platform is the definition of your network architecture, and in particular, your VPCs. Creating a VPC, if you have tried to do so, and if you have gone to the endpoint platform and you have tried from Runtime Manager, is a very, very simple process. All that you have to do is to provide the values for these 4 parameters: the region of your VPC, the CIDR block, the environments, and the business groups. So technically speaking, it could take you less than 2 minutes to create your VPC and to get it up and running. However, it is extremely important to understand these parameters and the impact of the values that you are putting in these parameters and the implications of them in your network architecture. Because if we don't do it correctly, we can have a huge impact on your network architecture and the way you deploy your applications in Cloud Hub. And sometimes the first thing to understand is whether or not we need a VPC and why. So first things first, what exactly is a Mule VPC? Well, if you have created your application in Endpoint Studio and you want to deploy it in Cloud Hub, when you go to Runtime Manager and you deploy this application, you publish this application to Cloud Hub, this application will be run by one or more instances of Mule. It will be run by what we call a worker. Okay? Technically speaking, behind the scenes, behind the worker, what we have is a virtual machine, an AWS EC2 instance that contains an operating system, the Java virtual machine, the Mule runtime, and your application. We can deploy your application in one worker or multiple workers. When we don't have a VPC created, we can still publish our applications into these workers. So strictly speaking, you don't need a VPC to publish applications, okay? When no VPC has been created, these workers are deployed to a global shared worker cloud, which is the public segment of the Cloud Hub network that corresponds to your subscriptions. In some cases, when we need to publish a group of APIs for public access, this model is just enough, okay? But in many other cases, in the majority of them, there is a series of requirements to hosting your applications inside of a private VPC. A VPC is a virtual private and isolated network segment that we can create to host your Cloud Hub workers. Each Mule VPC will be created on an AWS region, and it will span across all the availability zones of the AWS region that we have chosen. If I'm not wrong, there are at least 21 regions across the globe in which we can deploy applications in Cloud Hub. Within each region, there are at least three availability zones, so that if an availability zone goes down, the others will pick up the workload automatically. That's provided out of the box with the AWS infrastructure. When we deploy more than one worker for our application, the workers are automatically deployed in different availability zones. So if I deploy my application in 2 workers, automatically these workers will be deployed into 2 different availability zones by default. Okay. Each Mule VPC will get a dedicated range of private IP addresses for your workers. And each Mule VPC will have its own firewall to secure access to the workers that we are deploying within this VPC. And having a VPC will allow us to establish a connection to your data centers, whether they are on-prem or they are in a cloud provider of your choice. But for this, to connect your Cloud Hub applications to your data center, you need a VPC. We can create as many VPCs as we want, but you need to understand how you are creating them, because usually the VPC is something that you want to be changing every day. Usually you create it, you set it up, and you won't be touching again unless you need to add another firewall rule, but this is not happening every single day. Also, for those of you considering creating a dedicated load balancer, dedicated load balancers are resources defined within the VPC. So first you need to create the VPC, and then you will create a dedicated load balancer inside this VPC. You can't create a dedicated load balancer with no VPC, okay? And you can't have a dedicated load balancer belonging to 2 different VPCs. Okay, so that sounds great, but now the question is, do I really need a VPC? When do I need a VPC? And why do we need to create a VPC for our deployment model? Okay, there are a few reasons why you will need a VPC. Some of the most important ones are the connectivity to your data centers, the level of isolation that you need to provide to your applications, the use of custom domains and custom certificates for your applications, and whether or not you need to use mutual TLS between your systems and your applications. Let's see them one by one. First of all, the connectivity to your data center. The applications that you will be deploying to Cloud Hub are normally integration applications or APIs. So in many cases, these apps require access to private resources or backend systems hosted in your data center, either on-prem or in the cloud. To secure the access to your data center, you can use any of the supported connectivity methods for Cloud Hub, which are VPN connections using IPsec tunnels, or if you have an AWS subscription for your data center, you can create a VPC peering between your Mule VPC and your AWS VPC, or if you even have a direct connection available in your AWS, we can also connect to that. But for any of these type of connections, we need to create first a VPC. You can't create any of these type of connections without a VPC. Another reason for having a VPC in your environment is the isolation for your applications. When we connect your VPC to your data center, the VPC becomes part of your network. It becomes another segment of your internal network. And as such, you need to secure the access to it. You need to control who is accessing this VPC. Do exactly with a VPC firewall, with the firewall that comes out of the box with the Mule VPC. Also, in some cases, you might need to have your applications in different network segments, in different subnets. You don't have to publish all of your APIs in only one VPC. Actually, in many organizations, not all the applications need to be accessed by the rest of the organization. In many of these cases, the different groups of applications need to be not only logically separated, but also it's a requirement that they have to be separated at the network level. They need to be in different subnets. And there are many reasons to do that. So some examples. In some cases, the applications that you will be deploying to your VPC might not be public, okay? There can be a group of APIs, a group of applications that should be accessible only from your internal network. In that case, you need to prevent your applications in that VPC from being publicly accessible with the use of using firewall rules of your VPC. In other cases, you will have different types of traffic in your applications. So for example, it's a very good practice to segregate the traffic between production and non-production environments so that you don't have any test or non-production application getting access to production data. Okay, so in this example, as you can see, we have two VPCs, the production VPC and the non-production VPC. And each VPC has an individual connection, an individual VPN to one, the production environments, and the other one with another VPN connection to non-production environments. Okay, this is how we can segregate traffic with two VPCs. Another example could be differentiating traffic between business units in the same organization. For all these cases, we can use business groups and create your VPC as a resource only available in that business group, okay? So for all of these cases, you need a VPC. The last most common reason for a VPC is when we need a dedicated load balancer, as we said before. A DLB is a resource that must be defined within a VPC. When do we need that dedicated load balancer? Well, four main reasons for that. First of all, the use of custom domain for your applications. When you deploy your application to Cloud Hub, it will be published under the name applicationname.region.cloudhub.io. If this is not enough for you, if you would like to publish your application under your custom domain name, you need to use a dedicated load balancer. Okay? And also, if on top of that, you are providing access to this custom domain name, to these applications under this custom domain name with HTTPS, you will need to add a certificate, a custom certificate that corresponds to your custom domain name. And for that, you need as well a dedicated load balancer. Another reason for a DLB is mutual TLS. When you need to do a mutual authentication between the system calling the application, and this authentication is done exchanging certificates, that is when you need to implement mutual TLS. And that can be done in any point platform using a dedicated load balancer. Some examples could be a mutual authentication between Salesforce and Mule applications, or between your Mule applications and Heroku Postgres databases. All right, great. So now, based on all of these cases, on all of these examples, we know that we probably need a VPC for our Mule applications. But the question now is it enough with one VPC? Do I really need more than one VPC? And if so, how many VPCs do I really need for my deployment? How do I know how many VPCs I need? Let's have a look and let's see what you should consider to calculate the number of VPCs. In our case, if we are going to be connecting our VPC to our data center through any of these supported connectivity methods that we have available in any point, to provide your Mule application access to your backend systems, the first question we need to ask ourselves is where that backend is located. As we mentioned before, the Mule VPC will be created in an AWS region. So the first recommendation, obviously, would be to create this VPC as close as possible to your backend system and pick up a region which is as close as possible to your backend system to minimize the latency in the communications. However, in many organizations, especially in big organizations, they don't have a unique location for the data center. Their data center is geographically distributed in different on-prem locations or in different regions of their cloud provider. If that's the case, we've got two options. We could still create one VPC and create from that connections to each data center location. In this case, the latency would be different for each region. And what you would, if this option could be viable, is to assess if the furthest region from the VPC provides an acceptable latency. If not, you will need to create more than one VPC. And you will need to go to the second option, which is creating one VPC per region close to a data center location. And then set up a connection between each VPC to the data center location. So if, for example, our data center has locations in 3 main regions, in America, in EMEA, and in APAC, what I would be doing is create 3 VPCs, each VPC in one of the regions closest to America, EMEA, and APAC. And from every VPC, I will be creating a connection, a VPN, or a VPC peering, or a direct connection to the closest data center location. With this configuration, the latency would be optimal for every region. And the only downside that we could have is that the applications deployed to different VPCs will be isolated. They will be in different VPCs. They will be in different subnets. That could be the only downside. There is another consideration for the number of VPCs needed, which is the different groups of applications, APIs, and the level of isolation that we need to provide for each group. At this point, we need to talk about business groups and environments. As you probably know, business groups are a great solution to separate and control access to endpoint resources. A VPC is a resource that can be created at the master organization level and also at the business group level. And within every business group, we will define our environments and as logical groups for our applications. We can have multiple VPCs in our business groups, and at the same time, a VPC can be shared across multiple business groups. You could, for example, as we were saying before, you could define your production VPC, like this example, and another VPC for non-production environments. And we can share this VPC across all the business groups. So these 3 business groups will be sharing the same VPC. And from the point of view of the business group, the users of this business group will be seeing only the resources, the applications of this business group. But behind the scenes, all these business groups will be publishing their applications in the same VPC, in the same subnet. Okay. Another thing that is very important is when you create a VPC, that VPC is only shared vertically down, not up or across. And this is particularly important to understand because I've seen a few cases in which we have to find the VPC at the deepest level of the business group hierarchy, and soon later we had to define another VPC because the original VPC could not be shared with other business groups. So if we have a look at these examples, if I created the VPC at the master organization level, all the business groups would be able to use this VPC because all the business groups are children of the master organization. However, if I created my VPC at the business group A level, or the other example, at the level of the business group B, this VPC can only be used by that business group and the children of that business group, okay? That cannot be shared up or across. So the master organization or the siblings, the other business group, won't be able to use that VPC. So be very careful where you define your VPC, okay? And if you don't have any requirement in terms of isolation between business groups, the recommendation is to define your VPC at the master organization level, so you won't have any problems in the future. All right, let's now talk about environments. An environment is that is the way we group our applications, and the way we group all of these applications in a business group. Every application we publish will be published into an environment, and we can create multiple environments for every business group. Environments get associated to a VPC. The key here to understand is that we can have multiple environments in the same VPC, but each environment can be associated to only one VPC. So in other words, one environment cannot be part of two VPCs. This way, every application we deploy gets deployed to an environment, and that environment is associated to a VPC. We don't have any settings to link directly an application to a VPC. The application gets hosted into the VPC associated to the environment you are deploying to. This provides us with a mechanism of isolation for our applications or groups of applications. Two environments associated to the same VPC will be logically separated, but will belong to the same network. However, two environments associated to different VPCs will be completely isolated from each other because the traffic between environments will be segregated. There will be different network segments. There will be different subnets. The recommendation, once again, is to have a minimum of two VPCs, one for production environments and the other one for non-production environments. All right, let's now talk about the CIDR block and how to choose the right size for your VPC. The CIDR block is one of the most important decisions you will take in your VPCs, and you need to do it right, because once your VPC is created, you won't be able to change your CIDR block. But first things first, let's start from the basics. What is an IP address? An IP address is the numerical representation of a location in a network. So similarly to how your cell number identifies your cell phone in the whole world, your IP address identifies your device, your server, your network interface in a network. And as we know, the computers only understand binary numbers. For that reason, an IP address is just a sequence of zeros and ones. To be more specific, it's a 32 zeros and ones, 32 bits. We obviously, as humans, we need another format. Okay, that's why usually you see an IP address represented in a group of group of 4 decimal numbers. What we do is we split the IP address in 4 blocks of 8 bits, and we use the decimal representation of every octet of the IP. So in this example, for example, 192 is the decimal representation of this. 168 is the decimal representation of the same number in binary, and so on. Okay, great. So that's how we represent an IP address. Now let's see what exactly is the CIDR notation. CIDR stands for Classless Interdomain Routing Notation. This is the notation that we use to identify networks and hosts in the networks. You need to think of a network as a collection of devices, computers, servers, in general, anything that have a network interface. And in general, we call that a host. A host is just something with an IP address associated. In terms of IP addressing, to create a network or a subnet, we take a segment and a space of consecutive IP addresses from the whole IP addressing space. So with that in mind, the CIDR notation, which is an IP address / a number between 0 and 32, helps us identify the network and the host in that network. Using this notation, the CIDR notation, we take the IP address and we split into 2 blocks of bits. The most significant bits, the network prefix, represents the network, and the second block identifies the host in that network. Why is this relevant for your VPC? Well, because when we create a VPC, assigning a size for that VPC, we are defining the number of IPs that we can assign in our VPC. So for example, in here, in this network 192.168.00/24, that represents a range of 256 IP addresses. Okay? The number that we have after the slash, in this case 24, represents the number of bits that we will use to represent the network. Okay, so we take 24 bits to represent the network. So all the hosts, all the network interfaces in this VPC will have the same prefix. We have the same first 24 bits, and we will use the remaining 8 bits to assign IP addresses in our network. Okay, with 8 bits, in this case, we can assign up to 2 to the power of 8, which is 256 addresses. That's the size of our VPC, 256. In this other example, in a /16, we will use 16 bits to represent the network and 16 bits represents the host in that network. Okay. In this case, the size is much bigger. The size is 2 to the power of 16, which is 65,536 IP addresses. So this is a much larger subnet. It is very important to pick up the right block size for your network. Here in this table, you have the relationship between the number of IP addresses and the block size. The thing that you need to remember regarding MuleSoft and the Mule VPC is that the minimum block size that you can choose is /24. So the minimum subnet, the minimum size of a VPC is 256 IP addresses, and the maximum number that you can choose is /16, which is 65,536 IP addresses. Okay. Again, the size of your VPC is very important. Remember, you can't change it. So if you provided a short block, you might run out of IP addresses and you will have to create another VPC and move your applications over if you needed to get a larger size. Okay, that could have a huge impact on your deployment in your organization. From that point of view, well, you might be thinking, why is that such a big deal? Why don't we just, every time we create a VPC, why don't we just assign a /16 size? Why don't we just assign the and forget about it, right? The thing here to think is that the moment we connect your data center, these private IP addresses in the VPC will be part of your internal network. So we will be reserving this range of IP addresses from your internal IP addressing space. So it is important not to oversize your VPC. You also need to think that for many organizations, MuleSoft is not the only system or platform. So you can imagine if all the software providers will be requiring a VPC and we would be assigning an /16 to all of them, we sooner or later be running out of IP addresses. So we need to be very careful with this. All right, so the question then is, how do we estimate the number of IPs that I need for my Mule deployment? And for that, the number that we need to look at is the number of applications that we will be deploying in our VPC. The key here to understand is that there is no a one-to-one relationship between applications and IPs. Remember, the number of IP addresses in your server block is not the same as the number of applications that you want to deploy. Okay? It's very likely that one application will consume more than one IP. The key concepts to understand and to look at to do a proper estimation for your server block are the following. First of all, the number of workers. As we were saying, when we deploy a Mule application, we will deploy it to one or more workers. Every gets its own IP address. So an application deployed to one worker will take one IP, and the same application deployed to 4 workers will get 4 IPs. You need to estimate as well how many workers your applications need. There are mainly 2 reasons to have more than one worker to your application. One is horizontal scaling. So some apps, due to the type of processing that they are doing, they require more than one worker to distribute the load between the workers and get better performance. And reason number 2 is high availability. If your application is critical and you need to add additional workers to that, if your application is critical, you need to add more workers to that. Because that way, if one worker fails, the application can continue serving requests with the other workers. Another aspect you need to consider is fault tolerance in the region of the VPC. As we were saying, the Mule VPC will be created at the region level, and it will be spanned across all the availability zones. If we want to provide fault tolerance for an eventual downtime of an availability zone, we need to create as many workers, we need to provide as many workers as availability zones you have in that region. So you need to look at what region you are deploying to and have a look at how many availability zones you have in that region. So for example, if we are creating our VPC to the Frankfurt region, which is 3 availability zones, that means that if I want to provide fault tolerance under the downtime of an availability zone, I need to create 3 workers, at least 3 workers for that application, which means 3 IPs for the same application. The other thing that you need to consider is zero downtime, which I guess most of you are familiar. Zero downtime deployment is, I would say, it's a deployment style. It's a type of deployment that allows CloudHub to deploy new versions of an application or new runtime version without the interruption of the service. With this technique, we can deploy new versions, new runtimes. We can scale horizontally or vertically with no interruption for the consumers of that application. Zero downtime leverages a side-by-side deployment. If we do any of these operations, what CloudHub would do is it will spin up a new worker side by side the old worker, and for a period of time, both workers will be running simultaneously. Okay, when the new worker is ready to accept all the traffic, the old worker will be switched off. But for that period of time, we will have 2 workers, which means that we will need 2 IP addresses. Okay, so the thing here to understand is when we do any type of these operations, that we will be duplicating the number of IPs. So if we do a bulk operation that involves the upgrade or the update of a group of applications, the number of IPs required is the double the number of the workers. Okay. So in this case, you need to leave enough IP addresses free to do this type of operations. The recommendation is, in the worst case scenario, is to consider 2 times the number of workers to duplicate the required IPs. And the last thing to take into consideration is the number of environments. Each environment that we use and the applications we deploy on it will be hosted in one and only one VPC. The same environment, as we were saying, cannot belong to 2 VPCs. So normally, the same application will have a version of the application in production and another version of that application in every environment. For example, in dev, in QA, and test, for instance. For that reason, we need to consider how many environments I will be using, and if I'm going to keep a version of every production application in environments. Because if we do so, we will be multiplying by 2, by 3, or by more the number of IPs required for the same application. Okay, so you need to ask yourself, are we maintaining a version of the app in dev, in test, in QA for every version or for every application that we have in production? Okay, that's the question you need to answer. All right, so these are all the considerations to choose your CIDR block correctly. Let's have a look at a couple of examples. So let's see, for example, for a block size of /24, which is 256 IP addresses. Let's see in a particular example with some characteristics of our domain, how many applications I can deploy. So the first thing we need to do is to take out a couple of reserved IP addresses, the network address and the broadcast address. So that leaves 254 IPs. Now, let's say that in our case, we want to provide fault tolerance. So I want to be ready if any availability zone goes down, and I'm deploying to Frankfurt. This means that for every application, I need to create 3 workers, and that means that I will be the maximum number of applications in this case for now would be 84. Okay. This is going to be the VPC for a production environment, so I don't have to divide the IP addressing space with other environments. And if I consider the 0 downtime, worst case scenario, I will need to divide that by 2, which means that the maximum number of applications in this block size is 42 applications. So as you can see, there is no one-to-one relationship between the number of applications and the number of IP addresses, which is 256. Another example, let's take from the previous example, these 42 applications, and let's try to estimate the size of the VPC for the non-production environments. Okay, so in this case, we have 42 applications to deploy, which means 42 workers, which means 42 IPs. Let's say that for non-production environments, I won't be providing fault tolerance for the availability zones. What I will be doing for my test and for my dev is to provide 2 workers per application, which means that I will need 84 IPs for now. Let's multiply that for 3 because I want to keep a version of every application in 3 environments, dev, QA, and test. And let's multiply that again by 2 because I want to be ready if I want to do a bulk update for all the applications. If you do the maths, that means 504 IPs that we need, which is a block size of minimum /23. So as you can see, under these conditions, the block size is bigger than the, for the non-production VPC, is bigger than the production VPC. And the last example, let's say that we want to deploy 1,000 applications to a production environment with some characteristics. So if I want to deploy 1,000 applications, that means 1,000 workers minimum, and that means minimum 1,000 IPs. Let's say that I want to provide high availability. So I will be deploying 2 workers per application. That means 2,000 IPs minimum. This is going to be a production environment, so I don't have to multiply that for anything. And let's consider also 0 downtime. With that, it gives us 4,000 IPs that we need. It gives us the block size of /20. So I need a /20 CIDR block size for 1,000 applications. Okay, those are some examples. All right, with that, time to wrap up and to review what we've learned today. We've seen quite a few things. We've seen what is a mule VPC, what you can do with a VPC, and why you might need a VPC for your Cloud Hub deployment. We've seen that you can create 1, 2, or many VPCs, and we've analyze the main drivers to choose the right number of VPCs required in your deployment. We've seen as well that creating a VPC is a very simple process, but you need to choose very well the configuration of your VPC. We've seen what is the impact of all of these values in your network architecture, the region, the environments, the business groups, and we've ended up reviewing how to properly estimate the size of your site block, the size of your VPC. With that, I hope that now you feel much more comfortable when it comes to creating your VPCs. And well, if we still have some time, I think we can open it for questions. So, Angel, not sure if you have seen any questions in the chat.
Yes, excellent, Gonzalo. Thank you very much for the very deep dive that you made there and the great presentation. We do have a lot of questions, actually. Some of them have been already answered. So I will ask, please, to Doug Chan, to Harsh Kaul, Hakshay Sonahe, just to write down if they still have the question pending or it was already answered. Now, let's start with 5 different pending questions we have. One from Jonathan Ben Hamo is, do you still have, sorry, 1 second. There is no VPC pairing between MuleSoft VPCs. Why is the reason for this? That would be the first question.
That's a very good question and a very often question. Yes, that's correct. For now, we cannot establish pairing between Mule VPCs, but all that I know is that it's in the roadmap. This is not the first customer that asked about it, and what I cannot tell you exactly is when that is coming. But this is something that is included in the roadmap. Yes.
Okay, thank you for that, Gonzalo. So the next question is from Harinata Kasiredi, and it's about if it's a thumb rule will be IPs should be more than applications at any time if we see it fit. Is this correct?
So I didn't get the question. So
is it a rule of thumb? You have the will be IPs should be more in quantity than the applications that we have at any time. I'm not
yes,
sure if
definitely.
Okay.
Yes, definitely. As we were saying, there is no one-to-one relationship between applications and IPs. And it's very likely that you will have more IPs than applications. Okay. The rule of thumb that we usually give is 10 times to have the number of IP addresses is 10 times the number of applications. But again, it really depends on all the considerations that we were seeing before. So what I would encourage you is to do a deep analysis in what is the region you're deploying your VPC, if you are deploying with high availability, fault tolerance, the number of workers, consider zero downtime. That would be my recommendation.
Okay, thank you for that, Gonzalo. The next one is from Ankur Buyan. It's about what do we suggest from the MuleSoft side? Will 2 VPCs be enough for small-scale applications, or do we need more?
Well, actually, if I'm not wrong, with the basic subscription, it comes with 2 VPCs. And the recommendation, as we've seen during the presentation, is to have 1 VPC for production environments and another one for non-production environments. Now, whether or not this is enough, I can tell you, it really depends on the customers. There are customers that they need to isolate different groups of applications. So if you need to isolate these applications, you need extra VPCs. Or there might be customers reasons they need to get the test environments from the pre-production environments. So in that case, you need an extra VPC. So the minimum recommendation is 2 VPCs, but again, it really depends on the requirement of the customer.
Thank you for that, Gonzalo. There is 2 questions for IPv6, one from Ronald Rios and another one from Prasenjit. The first one is if it's supported, and the second one, sorry, Let's go first with the Ronald Rios question around IPv6, if it's supported.
IPv6, as far as I know, I'm not 100% sure, but I think it's not supported. But I won't be putting my hand on the file, so I will double check with that, and we'll get back with an answer.
It's not supported. That can be found on one of the documentation links I've shared there in the chat.
There you go.
Thank you for that, Sebastian and Gonzalo. So in the second case, okay, it's not supported, so that won't be a part of the question. So the next one is from Victor Corso. What happens in the case of redeployments, zero downtime, if you don't have more IP addresses?
Well, in that case, you won't be able to redeploy. Okay, you need to consider that the workers that are currently running are taking an IP address. When you redeploy or you do any type of operation that requires the spin up of a new worker, that new worker cannot start because there's no IP address to associate to that new worker. So you won't be able to do any type of vertical scaling, horizontal scaling, any type of update.
Okay, thank you for that, Gonzalo. There was another one related to that. I'm not sure if it was already answered. It's around from Jonathan. For zero downtime, you have 2x capacity. Can you provide an example of when will all the applications be deployed contemporaneously? Is that 10 or 20% factor a more realistic yet safe estimate?
I don't have a number. What I can tell you is some questions that you can ask. I don't think there will be a situation in which all the applications will be updating at the same time. The questions that you need to be asking yourself is how many applications you will be updating in parallel are part of the same solution. If you have different groups of applications that need to be updated at the same time, if you have how many versions of the runtime you are running simultaneously, because if you have, for example, an update of a version of the runtime, you will be updating all of them at the same time, and also have a look at the security and continuous patching that we are doing as part of our MuleSoft policy when we update the security patches. Okay. Also consider what type of traffic you have for your applications. Do you have a group of critical applications in your deployment that you typically scale vertically or horizontally to accommodate peaks of traffic? These are the type of questions that I would ask. For sure, if we have 2,000 applications on 20,000 applications, I don't think, even if we do a security patch, that we are able to update 20,000 applications at the same time. But what we do, the rule of thumb, just to be sure that we have enough space in our VPC, is to consider 2 times the number of workers.
Gonzalo, thank you very much for all the answers so far, and apologies because there were a couple of them that we won't have time right now. We need to move on to the next session that will be from David.
Okay, in that case, I will stop sharing.
Thank you very much for the session, Gonzalo. And David, before you start your session, and because I made the mistake of not starting the recording sooner, just take a look at the safe harbor statement. Again, the sessions that you will be seeing today could have roadmaps being mentioned, but this shouldn't affect your business decision. You should always see the public releases that are coming from MuleSoft, whether in the Connect or the public materials in the web pages. With that, I close the cap, and we can go back to you, David. Thank you once again, Gonzalo. Very deep conversation we had.
You guys.
Thank you, Gonzalo. Okay, let me share my screen and let me know if you can see it.
it, and we can hear you all right, David.
Perfect. Okay, thank you all for attending this meetup. Hope everyone is safe at home. I'm David. I have been working with MuleSoft for around 5 years now. So I mainly in professional services, but I always collaborate with different teams like pre-sales, engineering, product. So I have been in the company for a while. The topic that I'm going to cover today is metrics framework. So again, a safe harbor here. Some of the topics and applications, tools that we are discussing in these meetups are sometimes open source, sometimes they don't have support. So it is important to understand that this is, as Angel said, you shouldn't be considering this material to make real business decisions. It can help you on getting there, but you shouldn't be considering this as a final statement from the product or an official statement from MuleSoft. Okay, so the content that we are going to cover today is a little bit of an introduction and context around metrics in general. What is the metrics framework, some definitions, features, and I'm going to perform a quick demo on how this works. So let's start with the introduction and context. So in any software project, we have to, or we want to measure things, right? We always want to get clear KPIs and dashboards to make decisions based on data, based on numbers, right? Like we want to understand the developer's productivity. We want to understand the capacity that we have in our servers in terms of CPU, memory, if we are getting out of capacity, if we are achieving specific goals based on reuse and other quality attributes, high availability, if we are prepared for this disaster recovery scenarios and so on. So we normally talk about metrics and KPIs a lot. And when we have to obtain these numbers, is really a complex task, right? So in the context of MuleSoft, we always talk about big cores, right? Transactions, reusability, discoverability of the assets, adoption of the platform. And we don't have this information ready to be consumed in a form of a dashboard, for instance, right? So in the previous years, we have been doing scripts and tools to gather these numbers using Anypoint Platform APIs because the information is available, the raw information is available as part of Anypoint Platform. You can get, using the Cloud Hub API, you can get all applications and then you can count the big cores for the specific environment. Or you can call the GraphQL API from Exchange to understand the assets that you have there and the dependencies, if you are reusing fragments and so on. So in the past years, we have been doing these custom tools to gather this information, right? Because we need these numbers to make decisions and to understand how the platform is used for every single account. So the metrics framework is basically an extensible Mule application that collects, aggregates, and can load these metrics into different visualization systems. So the main source is Anypoint Platform APIs, Exchange, Runtime Manager, Design Center, Cloud Hub, Runtime Fabric APIs, and the application orchestrates all these APIs and generates specific metrics that we are going to see later that you can load in Splunk and in other visualization systems. So before jumping into the features of this application, it is important to understand the difference between a KPI and a metric, right? Normally we talk about KPIs, and that's the final goal, is the strategic business index that we need to, or we want to have as part of our analysis or as part of our dashboards. However, if we don't have metrics first, basic metrics, we cannot obtain in an automated fashion any KPI. So thinking in KPIs is fantastic. That's the right approach. But when you implement the automation for obtaining KPIs, you have to use a bottom-up approach. Thinking in base metrics first, then you can compose these metrics, and at some point you can generate a KPI. So a quick example, a basic metric would be the number of APIs that you have in the API specs that you have in your organization, an endpoint platform. Sounds to be super simple, but I'm pretty sure most of the time we don't have an automated way to get this number, right? Number of applications for a specific environment, right? Normally we have to count one by one, or maybe calling the Cloud Hub API to obtain this information. So these basic metrics are not currently available as part of the, let's say, endpoint monitoring or other features in the platform. So the only way to gather this information is by yourself, right? Calling APIs and doing some counts, doing some basic map operations to aggregate these metrics and to generate composed metrics. So once you have composed metrics like number of APIs grouped by type, by business groups, by environments, and so on, you can start collecting and generating these values. And if you draw these values in a timeline chart, you will see a behavior there. And with this behavior, the graphical behavior, you can generate KPIs. And these KPIs are different in every single organization. Maybe for small organizations having a let's say, a growth rate of 2 big cores every 6 months is okay. But maybe for a large organization, that means something that we need to evaluate, right? Maybe the platform is the platform adoption is not right. Maybe the teams are not using the platform properly, or maybe we can improve something to generate collaboration across teams. So this KPI, once you have the metrics, that the metrics are facts, you can build KPIs based on the context of the specific organization, based on the context of the specific team that you have in your organization. So it's really important to understand that a KPI for sure is composed by one or multiple metrics, but a metric itself is not necessarily a KPI. By collecting these metrics over time, as I mentioned before, and drawing them in a timeline chart, you will see the behavior of these specific activities, right? And you can create KPIs that make sense for your organization. So the metrics framework helps you doing that. Here you have an example, and these are screenshots from the metrics framework. You have something simple, like the current count of exchange assets for a specific organization, right? 40. But from this number, you have a chart that shows you the type of asset, right? So this is great because with this chart, we can see that most of the assets in exchange are API specs, and we have applications, binaries as well in this organization, and other types. If you draw these numbers into a timeline chart, you will see the behavior, and from here you can start defining KPIs like platform growth or platform adoption, right? We can see that at some point these the number of assets is increasing. That might be positive or negative. It will depend on your organization. So the analysis is super important. And it is really a key factor to map the KPI categories with the metrics that you have available and the interested audience or personas, right? So in the case of platform demand and growth, the metrics, some examples of the metrics available: cores, B cores, allocated versus available. Sometimes these numbers are really important for the program leadership and sponsors because they can understand the capacity that you have left in your organization and invest some money to get more B cores, for instance, or for the platform architect to be able to support the demand of developments, right? Understanding the capacity that you have available versus allocated. The same for API specs, published versus API implementations related to these API specs, right? API calls, transactions, active, inactive users. So you have multiple metrics available. The important thing here is the analysis and map these metrics to specific KPI categories and the specific audience. So going back to the features of this Mule application, it's a compact Mule application, one single Mule application, super easy to configure and install. And it provides three different categories of metrics, anypoint platform metrics, more than 120. Actually, we are currently exposing 140 or so, calculated from anypoint platform capabilities like Exchange, API Manager, Anypoint MQ, Access Management, Runtime Manager. It provides as well an extension, the SDLC metrics extension, that it basically let you connect the framework to external systems like Jira, Confluence, that sometimes we need to gather metrics from these other systems as well to understand, for instance, the open issues that you have or open stories that you have, or maybe the number of jobs that you have in Jenkins, failed versus successful jobs. Then you have platform benefits as another category here that basically you can include some manual metrics and aggregate these manual metrics with, for instance, the reuse of assets and generate new metrics. This framework provides two modes. It exposes an API that you can consume from any external system, and it can be executed as a poller. So you can run this application in an automated fashion to collect, aggregate, and load these metrics into different visualization systems. So for the visualization options, we have plain formats like CSV, JSON, plain log, but we have loaders specifically for Splunk, ELK, anypoint monitoring, in the case that you have an account with Titanium. And specifically for Splunk, we have 14 dashboards with more than 150 charts available to build your, that you can pick the dashboards that are relevant for you and build your own dashboard that makes sense for your specific organization. And we have a set of basic Kibana dashboards for ELK as well. So here you have an example of the response of the API. In the case of a JSON response, you have a canonical model of a metric. You have the name of the metric, like API Manager, API instances with one or more consumers. You have the value of the metric. You have the business group, the date, and some classifiers like the environment and the group for this metric. If you generate the metrics using the CSV option, you can load that in any spreadsheet, and you will see metrics in this format. And for the specific case of Splunk, you will see that we have multiple dashboards available, and each dashboard provides a lot of information related to a specific product. And we have a consolidated dashboard that, as an example, to show multiple charts from different products, right? Like API Manager and Analytics, Design Center, Exchange. You have a Cloud Hub, RTF, standalone runtimes. I'm going to show you a quick demo on how this works and how these dashboards look like. Here you have an example, a quick screenshot of a consolidated dashboard without timelines, meaning that here we have just the current values, no historical information, right? So we have Exchange assets, we have Design Center assets, the reuse that is calculated using the Exchange GraphQL dependencies query. For instance, how many fragments or the average of reuse of fragments within API specs, or the reuse of extensions in API implementations or binaries deployed into Exchange. In the case of specific features like Cloud Hub, Runtime Fabric, access management, and so on, you will see that the dashboards have the timeline, right? So that you can collect these constantly, let's say once a day or once a week, and at some point you will see the behavior of the specific activities, and on top of that you can create KPIs. And actually, if using Splunk, you can create alerts, you can create notifications. So as I mentioned before, the goal of this is to define KPIs on top of these charts, right? KPIs that make sense for your specific organization. And the metrics framework is going to help you gathering these basic values and providing you out-of-the-box features to draw these values in dashboards. So there are multiple considerations, of course. Anypoint Platform APIs have rate limiting, multiple of them. So for large accounts, let's say that you have an account with more than 25 business groups, each business group with multiple environments, and in each environment you have multiple APIs, right? Multiple applications. You will receive a 4 to 9, basically because of the rate limiting policy. So there are some options. You can limit the business groups, because this is the framework iterates over all the children business groups, not only the master, the one that you define. It gathers information from all the business groups available for a specific organization. So you can restrict the business groups by using the ignore lists, or you can define specific collectors. The collectors are basically flags to enable or disable specific features. For instance, if you don't want to get information from Runtime Fabric because your organization doesn't use Runtime Fabric, you can just define in the collectors string, you can just remove the Runtime Fabric flag. Or same happens for any other product. If you don't want metrics from standalone runtimes, same. Another option is to use different schedulers with different cron expressions. For instance, you can use a metrics framework for one organization, maybe collecting information in the morning. Then the same framework, the same application can run in the afternoon, collecting information for other organizations, so that you don't hit the rate limitations there. Or you can include a retry strategy. in specific collectors, this is a Mule application, right? And you can change the code. You can add specific integrations and add specific features based on your needs. So you can add a retry strategy in the specific collectors. We are going to see how the code looks like as well. And we have to consider the permissions needed in any point platform to use this application, right? So some information or some API calls require organization admin access. For instance, if you want to get information about the client applications that your organization has, you need the organization admin role. But for most of the other metrics, you need just the specific permissions, like read applications in Runtime Manager or developer in Design Center, and so on. So we have the complete list in the documentation that I'm going to show you, the complete list of permissions and limitations that we have. The polar frequency, as I mentioned before, this is a metrics framework. So collecting metrics once a day or once a week should be enough, right? If you want to see real-time information, that would be a monitoring tool, right? This is not intended to be a monitoring tool. You already have other options. Anypoint monitoring, you have a lot of charts there with near real-time information, or you can send that some information from the platform to external systems as well. If the goal is to monitor the platform and to operate. This is a metrics framework to create dashboards that are going to help you building KPIs to make decisions for your organization and to be proactive, multiple aspects, right? So for large accounts or large implementations, maybe the loading metrics without an intermediate stage is not a good option. This will depend on the goal of collecting these metrics. So we have seen that sometimes a database or a data warehouse to move the information first is a good option for these cases. Let's say that you don't have Splunk, right? And you just have Power BI or Tableau. These tools don't have storages, right? You have to store the information in a different place, in a database, in a data warehouse. So for this type of organizations, maybe an intermediate staging place is the right option. So we have as well the SDLC extension that basically help you to collect, aggregate, and load metrics from other systems like ServiceNow, Jira, Bitbucket, and so on. As I mentioned at the beginning, it's important to gather metrics from your SDLC tools, right? Because by mixing these metrics with the operational metrics from the platform, you can build other KPIs. So the current features that we have so far are integrations with Jenkins, Jira, Confluence, Bitbucket, and Splunk. To gather specific information, you have specific examples, some metrics from Jenkins, Jira, Confluence, and you can enable or disable these collectors as well. Based on the framework structure, you have the same options. You have the polar and API modes, and you have the ability to fetch raw data as well. So this is an example of this type of metrics in JSON format. You will see Bitbucket repositories, Confluence pages, top contributors, Jira metrics like tasks by type, and so on. So this
Are you able to hear David? Please write it in the chat. Oh, sorry, David. I don't know if I was the only one, but it seems that it got stopped when you started this slide.
No.
If you can please recap.
You 1 minute.
Okay, so when I started this slide, okay, sorry. I was saying that this is
We
an
lost you
example.
when you were finishing to explain the different systems you can integrate with.
Okay. Okay, thank you. So let me go back here. Basically, with this SDLC extension, you can enable or disable the different collectors for these systems. And you have the same features consistent with the whole framework, right? The polar and API modes as well. Here you have an example of the different metrics that you can obtain with this extension. And this is to help you building something that makes sense for your organization. Maybe these specific metrics don't make any sense for your specific teams or your specific needs to build KPIs, but at least in the framework, you will have a baseline to integrate with all these systems and gather the specific queries and metrics from there. And this, of course, is extensible in general. It's a Mule application. You will see that it follows known best practices and a super clean structure where you have aggregators, collectors, loaders, sources. So in the case you want to add, let's say, an external system to gather information from XYZ system, you have clear steps to extend the framework, right? You have to include a new source, then a new collector, and based on the information provided by the collector, you can include this new metric in the aggregator, right? That is basically a data with mapping. And you have properties, clear properties, defined secure properties and plain properties as well. So you have, for those who know Mule and how Mule works and how to develop Mule applications, this is super straightforward to understand the framework and to extend it in the case you need to do that. Of course, all these analyses around KPIs and the mapping between the metrics available and the KPIs that make sense for your organization and the installation itself of the framework and the different visualization options. We have MuleSoft professional services. We have customer success teams that can help any organization or any partner doing these analysis. So please feel free to contact your specific MuleSoft partner or professional services representative to get more information about the metrics framework and different offerings. However, the framework is an open source application. So let's go and see how this is structured, right? You will find the source code in MuleSoft Catalyst metrics framework M4, because this is for Mule 4. And here in the README, you should have all the documentation you need to understand all the features, limitations, installation, and mainly all the metrics available. So this is part of what I explained before: the operational metrics, platform benefits, external metrics that you can collect, the two different modes, the loader options, and the available metrics. And here you have a big list with all the metrics available that you can obtain using this framework. Metrics from access management, from design center, exchange, API manager, runtime manager, depending on what you have. Let's say if you have Cloud Hub, you will obtain a lot of metrics from Cloud Hub. If you have RTF, you will obtain metrics from RTF as well. Standalone as well. Anypoint MQ. And the example of manual metrics, SDLC metrics, the installation that is basically just clone this repository and be sure that you have the right credentials or a user with the right permissions in the platform. This works with a Anypoint platform user or with a connected app, client credentials. So be sure that you have the right permissions and you can deploy this anywhere. You can deploy this in Cloud Hub or in RTF or in standalone. For the taking, let's say, data from the tests we have been performing to this framework, this is super performant. So, and since it's not required to poller, let's say, multiple times a day or every, let's say, 20 minutes, you can, if your organization is not a huge organization, you can deploy this in a 0.1 core, just to give you a reference in Cloud Hub. And you can use a sandbox environment because we don't need to have this as part of any production environment. This is a tooling application, so you can deploy it in any available runtime you have. The steps, as I mentioned before, are super simple. Clone the repository, and you can test in Anypoint Studio. You have a Postman collection as well that will help you understanding how the APIs work. So for instance, here I have a Postman collection with all the available resources, and I executed the framework, the API, to obtain metrics from a specific organization. The credentials are provided in the headers, and you will obtain immediately the metrics. As you can see, the response time here was 2.76 seconds. So this is an example on how to execute this from a local workstation, right? The application deployed in Anypoint Studio. If we go to Anypoint Studio, you will see that it's a classic Mule application, but with a very well-defined structure and files, depending on the different collectors that we have, external systems, different loaders. And in the same application, you will see all the dashboards available that we have for Splunk that you can import in Splunk. So if we go back to the source code and to the README in the source code, you will see all the properties that you can change. You can modify the collectors that I was mentioning before to enable, disable specific API calls, like you don't want Anypoint MQ because you have a PC installation and Anypoint MQ is not there, right? So you can enable and disable different options. You have the two authentication modes or mechanisms using an Anypoint platform user and connected apps as well. And here you have the steps as well to create the indexes needed in Splunk and how to load these dashboards, these out-of-the-box dashboards in Splunk as well. You have the same for ELK. In the case of ELK, we have just a basic set of dashboards. In the case of Splunk, we have a lot of them. I'm going to show you. And considerations and limitations. The limitations are mostly around the different deployment models. If we are using the Gov Cloud in the US, or if we are using PCE, you won't have some specific metrics, right? PCE, you don't have analytics, or you don't have Anypoint MQ, right? In a Gov Cloud, you don't have specific standalone runtime metrics, right? So here you have all the limitations documented and some theory around the framework and how it works, how the collectors, aggregators, and so on, all the parts of the framework work. So you can see you should have everything you need in as part of the README. Here we have an example. So once you execute and load these metrics, here you have an example of the results, right? Let me expand these a little bit. You have, for this business group, for each business group, you have the list of metrics with all the numbers, right? This is a plain text, or this is a CSV format that I'm going to show you right now how this will look like in Splunk. And there we have the real value of all this. So if we go to Splunk, and if you imported all the dashboards, then you can start creating your own dashboard based on the charts available for each feature or product here. So a quick example is this dashboard. That is the representation of the current state of an account, right? For a specific business group. So the number of exchange assets classified by type, the design center projects, reuse metrics, transactions in the last 30 days, calculated from analytics, right? API manager metrics, how many API instances you have, how many contracts you have, how many consumers you have, that are basically the contracts you have for each API instance in API manager. Policies used, the list of policies used per environment. The existence of security policy. That's really an interesting chart for security compliance, right? You have number of workers, big cores, total versus used. This is for the case of Runtime Fabric, but you have other charts for Cloud Hub as well, and for standalone runtimes, right? The versions of the new runtime that you are using in RTF or Cloud Hub. With a simple chart like this, or with a simple table like this, you can see that you need a plan for upgrading the versions, right, of the runtimes at some point. With a simple chart like this, you will see that all the applications are started, so that's great. In the case you have multiple applications stopped, maybe it is time for doing a cleanup in the platform. So as you can see, even if you don't have KPIs, this dashboard gives you a platform 360 view that is really helpful for platform admins and for architects to check compliance and to check reuse of the platform. But the real value is creating KPIs on top of this, right? So each number will have a different meaning depending on your teams and your organizations. So if we collect this information, we have the timelines as well to understand how the big cores are used. And just as an example, how can you proactively ask for more budget, right, to get more big cores because your organization is getting out of capacity. Based on these timelines, you can calculate the growth. So there are multiple variables and multiple KPIs that you can include on top of these charts. So just a recap, right? The metrics framework is a Mule application that helps you collecting, aggregating, and loading different types of metrics into different visualization systems. most of the metrics are related to any point platform, specific products and features, like metrics collected from Exchange or calculated from Exchange, Design Center, API Manager, Runtime Manager. So it's really helpful from an operational perspective, but it's really important as well to define KPIs on top of these dashboards that will help you making decisions, right, at multiple levels in your organization. For that, you will have to perform an analysis on how to map KPI categories with specific metrics available. We saw the source code that is available in our MuleSoft Catalyst repository, right, with all the documentation information needed. So if you want to collaborate with the project, you can just fork this project and make a pull request. Or if you have suggestions or if you find any issue, you can just create an issue here. Just a reminder that this is not a MuleSoft product. This is an open source project, right? A Mule application, like any other Mule application out there. So you won't find any official support for this application. This is an open source project. We saw the results or the output of the metrics frameworks when using the API directly, right, in CSV format or in JSON format. We saw that we have a Postman collection that you can use to understand how the APIs work. And we saw how the dashboards look like when you use the Splunk loader, right? We have multiple dashboards in Splunk, and based on these charts, you can build your own dashboard that makes sense for your specific organization. We saw different dashboards like specific counts and group by type, but the value is on these timeline charts, right? Because by collecting metrics over time, you will understand the behavior of a specific activity. And based on that, you can create KPIs and make decisions. So thank you very much. I'm not sure if someone has any question.
Thank you for the great presentation, David, and for the quick walkthrough. We do have a couple of questions. We will start with the easiest one, and then we go to the more complex. So okay. The first one will be around if it's the utility, well, itself the metrics framework is available for any customer, or is only a Titanium subscription capability?
It is available as an open source project, right? The Titanium capability will let you load metrics in any point monitoring, but you can load metrics in other places or use directly the APIs. So Titanium is not a requirement for this. This is a Mule application that can be used without that subscription. The specific loader for any point monitoring, in order to send these metrics to any point monitoring, requires Titanium. But the framework itself does not.
Excellent, David. Meaning that anyone that is using can reuse the collector, the transformer, and then the loader of their choice, if it already exists, as in the case of Splunk, for example, they could reuse that, and they will be able, even if they're not a Titanium customer.
Yep.
Okay. The next question is around the performance. We're talking about 4 to 5% performance impact when we talk about monitoring, and the visualization. It requires a monitoring agent to get data required for its view. If visualization is enabled, does it add additional performance impact apart from monitoring?
Okay, this is a Mule application, right? This is not a component of the Mule runtime or a component part of the product. So as any Mule application, if you have a standalone runtime with multiple Mule applications, this Mule application will consume some CPU and memory, right? or if you deploy this application in Cloud Hub, it will consume the cores, right? From the tests we did for this application, since this has to run just once a day, the impact on the consumption of resources is minimal, right? And you can manage that just by changing the polar frequency or the cron expression to run this application maybe at 2 a.m. in the morning to avoid impacting other applications in the case of standalone runtimes, right? In the case of deploying these to Cloud Hub, you will be using 0.1 core, B cores. In the case of RTF, you don't have this problem. You will be using maybe 0.1 B cores.
Thank you for that, David. We have another one. This one is very quick. You mentioned that it's open source, and if people want to contribute, they are able to fork their repository and then create a pull request.
Yes, correct. You can just fork the repo and create your PR, and we will review and we will comment. Any feedback is really appreciated.
Excellent. So there was a question from Denny Pichardo, so keep that in mind that you're able to contribute as well to the framework. Next one is from Bharat Kalagara. I have been looking for a way to look at a chart that shows the MuleSoft connector versions used on different applications. We have all our applications in Cloud Hub. Did anyone look into something like this?
Okay, that sounds to be more, let's say, quality control or governance tool. I have seen some open source options out there. I have seen some internal tools that gives you that information, but nothing, let's say, officially supported by MuleSoft. You can do that with Maven commands. Let's say that you have access to the source code of applications. You can use the Maven dependencies plugin, and you can execute the Maven dependencies plugin on top of the source code of all applications, and boom, you will have not only the versions, but as well if the versions are outdated. So there are simple processes that can be included as part of your CI/CD process using Maven, where you can obtain this information.
Okay, excellent. Thank you, David. The next one is from Denny Pichardo. It's around feedback from what they have used so far. So we started to use the metrics framework at our company. We're seeing a lot of discrepancies with the API analytics metrics, even after adding a retry logic. In some cases, we get 0 transactions or different numbers, even after making the call right after. Are there any known issues or limitations with the API analytics calls?
Yes, we know those issues, and thank you for the feedback. Currently, as you know, we have endpoint monitoring, and the old tools for monitoring APIs is API Manager Analytics, right? So what we are using in the metrics framework is the Analytics API that is going to be deprecated at some point. We don't have support, internal support anymore for that API, because now we have endpoint monitoring. However, in endpoint monitoring, we don't have any real-time way to gather metrics or gather information. So we need to keep using the analytics API, and we have some limitations there. The API is not intended to be stable right now. We know that limitation, and that affects the transactions, the number of transactions metric, something that we have in the backlog, but we don't have any alternative right now.
Thank you, David. And this has to be one of the last ones. Apologies for the rest of the questions. It's again from a combination between Sunil Sangpal and Denny Pichardo around they started to find some calls falling and any set of issues or fixes like mentioned for the 409 error. And additionally, Yeah, sorry, go ahead, David.
What was the question? Sorry, didn't get it.
The question is first is from Sunil Sankpal. Yeah, that one. Started using and found a lot of calls failing. Any state of no issues, fixes for those like mentioned is for the 409 error. And then that is an extension. There's the question from Denny Pichardo right next to it after that we have submitted the issues in GitHub and around Splunk dashboard for multiple business groups. Oh no, sorry, that one is unrelated yet. So it's the one on top.
Okay, so basically, regarding the issues, yes, we saw that, and for ELK, actually, we fixed the indexes. So thank you for the issues, and for the Splunk aggregation, we are evaluating how to improve the dashboards. But since it is simple to change, you can just change the operations in the queries, right, in Splunk. So we haven't seen a better option to improve the aggregation when you have multiple business groups and you want to have one single chart for all business groups. You can just use the sum instead of the max. But that's up to you. I mean, we are evaluating anyway. So thanks for all the feedback. Regarding the specific issues around 409, that sounds to be a conflict issue in Exchange when you deploy a binary to Exchange. And I'm not sure if this is related to API analytics. However, yes, API analytics, as I mentioned before, we know that there are some limitations and the API there is not stable. So we don't have any solution right now, but we will update the metrics framework once we have something available in the platform.
Excellent. Thank you for that. We will need to move on, but before we do, there's a shout out from Denny Pichardo that is thanking so much for the metrics framework. They have used it already for basic queries and have been a huge help in starting to develop KPIs. So that's a part of the feedback you can take there, David. And again, thank you very much for a great session.
Thank you, guys.
Okay, with that, we move to the last session. Sebastian, you will have around 15 minutes, as expected before, and it will be around performance case, use case. Let's now you can take it from here.
Can you hear me, guys?
Sebastian, yeah, we can hear you perfectly. Are you able to share the screen as well?
Okay, let me see if I can share my screen. Yeah, before starting, thank you very much, guys, for all your presentation. David, Gonzalo, and thank you to you, Angel, for organizing this event. And I think I can start. So, hi, everyone, and thank you for joining us today on this online MuleSoft Meetup. My name is Sebastian. I'm an integration support engineer at MuleSoft EMEA region. Been here for roughly a year. Prior to this role, I was a integration developer. So I've been using Mule for almost 4 years. In today's session, I will be covering a case study on how a customer dealt with queue performance issues within the application. So this is today's agenda, and we'll be talking about a little bit about the customer, the main application issue, the backpressure mechanism, and also controlling concurrency value that they were not setting, the architecture layout, the way in which we reproduce the issue, the different test analysis we did in order to reach to a conclusion with the customer, and then the final takeaways. So let's move on to the next one. So yeah, a little bit about our customer. They are a multinational company that trades with oil, chemical, natural gas-related products. Also, they have more than 2,000 employees and over 10 years of being in the market. They are also I mean, of course, using MuleSoft heavily across the whole company. Here we have the application issue. Customer's application issue was the fact of having to define explicitly the number of messages that an MQ consumer application could process without getting unresponsive, restarted, getting frozen there, right? Without even putting any messages from the broker. They were expecting the MQ consumer, the subscriber application, to sort of magically auto-regulate the influx of messages from the Anypoint SQS broker. And their main concerns in this regard were mainly two, like why no back pressure mechanism was triggered when the application was choking under big messaging load. And the second one, why such a stress application couldn't just pick up messages from an MQ in a gracefully manner without the need of defining the number of simultaneous invocations in a flow, like, as I said before, magically starting to auto-regulate the number of messages at certain time, given the influx of messages. So I'll be giving some more details on this in the next slides. So now I'll be talking just quickly about the controlling concurrency and the fact that when it comes to pull like 100 messages from a queue, could be, a Rabbit, SQS, Cloud NQP, you name it. A way of optimize the maximum level of concurrency that a flow can use is by setting the max concurrency attribute that we can find within the flows that we might have within our application. So in every flow, we define the number of simultaneous invocation that such component, the component that you happen to be using inside of the flow, might be receiving at any given time. In this case, those components were queue listeners, subscribers to external broker. Well, in this case, it was Anypoint queue, this QS. So in terms of setting the right value for this configuration, our customer already had their sweet spot, like they already found the right value, but they somehow refused to control the concurrency. They were just hammering, sending lots of messages to the MQ consumer application, ignoring this value, not setting this value, regardless of the performance consequences of having the subscriber without setting this value. So the application was pretty much going in unresponsive states every now and then. They knew the reason, but they want us to try to investigate if we could see the back pressure mechanism. Apparently, they were not seeing this mechanism being triggered in the application, but as I will show you later in later slides, yes, I was able to see it. So by disregarding the previous configuration value, our customer was looking for the back pressure mechanism to be triggered in the hope of having the messaging spike being properly notified, managed. So back pressure can occur under heavy load. When the mule does not have resources available to process a specific event. This issue might occur because all threads are busy and cannot perform the handoff of the newly arrived events, or because the current flow's max concurrency, the value has been exceeded already, or hasn't been defined. If Mule cannot handle an event, it locks the condition with a specific message telling you about the flow name in which that particular exception is happening. And it's going to notify you about the flow source to perform any required action, as you can see here in this small snippet. So now we will move on to the architectural layout of the application that this customer was using for this particular application. So here we have the whole application landscape. Starting from the left to the right, we have the Mule Publisher application that generates a big messaging load, like putting messages like there's no tomorrow in the SQS. They were hammering the SQS with more than 50,000 messages, 75,000 messages. And knowing those spikes, they were using a 0.2b core, which I personally think is too little, I mean, to manage those expectations. They also have here like the anypoint enqueue with 5 queues bind to an exchange, the Mule consumer application with 5 subscribers listening to the MQ, which at consumption triggers an HTTP call, returning an acknowledge message to the client. So again, a no max concurrency attribute was set here in this application. And they were also using a sort of a suboptimal log appender to ship messages to a Splunk instance. You can, I mean, the recommended way of shipping messages to Splunk would be by using a Splunk HTTP appender, but in this case, they were using the one that's not recommended, and they were using it for the sake of trying to force and seeing this back pressure mechanism. They were on Mule runtime 415, one worker of 0.2b cores, used by each application, the publisher and the consumer. And that's pretty much it. I mean, now we have to reproduce the issue. I mean, to check that the back pressure mechanism wasn't being triggered, was or wasn't being triggered in the customer's application, we needed to run through the application and reproduce their force issue by having 2 different scenarios. Because they were using the HTTP logger appender, I thought, well, let's try to see what's going to happen if we don't use it. So I did to sort of test to see what the difference was at each stage. And also, we also need to prepare the scenario by first create a huge messaging load in the defined queues. Like I start sending like 75,000 messages and just loading up the queues for me to stop the producer and then start up the consumer to let it start pulling messages in a constant way. And then the second one is just, as I said, start pulling messages from the queues over a period of almost 20 hours. It was a little bit too much, but it was because of this HTTP logger appender that was being used within the customer application. Okay. So yes, now we will start off just talking about the different test analysis we did here. So up until now, I mean, the application has been left trying to consume all the queue messages for up to 20 hours. Remember, the application is currently using the suboptimal HTTP logger appender. Why that many hours? I mean, the thing is that we need to give enough time to the application and for us to understand what was happening behind. I mean, that we can log into the worker and see all the different AWS stats in regarding to the memory, the CPU, the credit balance, the credit usage, and we can produce a more articulated reasoning to the client, right? So to the customer in this case. So the fact that the customer was using this appender was just messing with the application, because when using this appender, the login system has to open a new HTTP connection for each batch of log entries. I mean, this results in a high number of connections being opened and in a long idle times during which the system waits for a response from the remote host in order to close the connection. In other words, this configuration is was very resource hungry, causing both the memory and the CPU high consumption, particularly if the logging is being used so heavily as it was in this case. A customer knew this already, but again, this was for the sake of trying to force the application to max up the application. I mean, to force the application up to the limit and try and seek that exception be logged anywhere in the middle of the trace application logs. This was part of the CPU utilization dashboard from AWS. I mean, here we see the CPU usage going above the 80% for the first hour, as you can see here. At that time, there's no limit on the AWS usage instance by the customer application. Right after that hour, as you can see here, the AWS policy, the credit balance, bring the available AWS computational resources for the app down to the 20%. I mean, 20% is not enough for our application to chew the load of messages, the more than 75,000, well, 55,000 messages that in this case the customer was pushing against the application. So also we need to adapt the bad performance added by the HTTP appender. We check on every log sent to the customer's Splunk instance. Just as a reminder, on AWS, a CPU credit is equal to 1 minute of a full CPU core running at the 100%. I mean, these credits are built up continuously, and the rate is up to the instance size. I mean, it's gonna depend varying on how many vCores are you gonna provision for your specific application. So here we see here we have the CPU credits usage and the balance. So this is the behavior when the application is consuming that many messages. During the first burst CPU hour, the application consumes all available credits, as you can see here, which allowed the customer application to run relatively okay when consuming those big spikes. But right after that hour, we see that the CPU credit usage getting down to the very minimum here, down to 2. And at this point, there's not enough credit to support any app execution at all. At least this application was doing nothing. I mean, it was not pulling any messages at all from the SQS. And the CPU credit balance here to your right shows how at the first hour it is all pretty much gone. I don't know if you can see here. Let me just hide this. Can you see my screen? Can you see my screen? Yeah. Sorry, guys.
That's good. Don't worry.
Yeah, I mean, while the CPU usage remains at the baseline, the 20%, more credits are being accrued. And you can see this here, and this is small, big, right? We have here these 3 spikes, which represent the points in which the customer application tries to make usage of more CPU at the very moment in which there's some more credit usage being accrued. But as soon as there's something to be consumed, it goes down to the bare minimum. So because of this situation, because it's very hard for the EC2 instance to build up more credits, the application was hardly taken off. So yeah, I mean, it's important to know the runtime is not aware of the existing of credit limits for the computational resources. So it assumes that it has the 100% of the CPU time of the machine to execute as much as it can, which is not true.